Hello, thank you for joining us today. I'm happy to talk to you about how to take your code from a horror story that nobody wants anything to do with to a fairy tale that other developers would like to read. When we're writing software, there are always software design goals that are maybe implied and not explicit. Some things that we need to do, but we don't always discuss that we need to do. If that makes sense. Some examples of this are that the program does what it is supposed to do. That seems to be pretty straightforward, but it's not always something that we explicitly state as a software design goal. What are some other implicit software design goals that you can come up with? Some things that I came up with include that the program does what it's supposed to do without any bugs, or perhaps without any security vulnerabilities. Your software should be easy to use. And another very common design goal is that the code should be easy to modify as the requirements change. Again, often these are not included explicitly in the requirements for our project, but they can be very, very useful in the overall maintenance costs of the software we build. One thing that's really interesting to note about these goals is that just one of these actually involves running the code on the computer. So as a developer, where do you find that you spend your time? You might say writing code. And sure, that's part of it. But maybe you spend a lot of time brainstorming. You spend a lot of time problem solving. One thing that comes up a lot when I ask this question of other developers is meetings. We spend a lot of time talking things over as part of our project. A lot of times we spend a lot of time testing our code. In fact, we may often spend more time testing our code than we do writing it in the first place, especially if we're doing test-driven development or similar paradigms. Another activity that we do is documentation or other types of project writing that aren't code. But what about reading code? The ratio of time spent reading versus writing is well over 10 to 1. We're constantly reading old code as part of the effort to write new code, and therefore making it easy to read makes it easier to write. That's a quote from the book Clean Code. Any code of your own that you haven't looked at for 6 or more months might as well have been written by somebody else. And that is known as Eagleson's Law. These are things that we need to keep in mind when we talk about reading code. It's a quote from Martin Fowler. Any fool can write code that a computer can understand, but good programmers write code that humans can understand. And all of these lead to the overall point we're going to get into over the course of this talk. But quickly, please allow me to introduce myself. My name is Michael Dowden. My pronouns are he, him. And I've spent a lot of years writing code. Some of those, probably horror story, because I didn't think about code as a communication tool with other developers. I thought about code as me telling the computer what to do. But we're going to get into that in just a minute. So the horror story. Let's set the stage. So here is an example of bad code that I found on the Daily WTF from one of their articles. And as you can see from looking at it, it's not super clear at a glance what's happening. That first line, you're converting from a string to a datetime object. It's a hard-coded string, and then you're converting it back into a string of a different format potentially, although short date string, the original string looks like it's a short date string, so maybe that's all redundant. And then we're converting that back to another datetime object in a different way, and we're doing a toString on that again, and then we're splitting that on a space, and what in the world is going on? And honestly, without writing tests or console log statements or something to figure out what's going on here, you're going to have a hard time deciding what the result of this is going to be. And when you have to spend a lot of time understanding the code before you can really get into it and add to it or change it or fix it, that can be a problem. Beware of huge cognitive load that can cause hours of work to figure out what the existing code does before we can make our one-line change, for example. Here's another counterexample from the daily WTF, specifically from the code SOD. This is very obviously somebody that tried to be very explicit in their naming conventions, right? They have these really long names using full words to explain what is going on. And at first glance, that seems like it makes a lot of sense, but let's look closer. Case inventory integration direction is do the same, change in shop. Do the same change as what? Maybe this makes sense when you understand the full paradigm and context of the code, but out of context, this doesn't mean anything. Get changed data from inventory. Why is it changed? So there's some explicit variables, but they're not super clear as to what's happening. It still requires a ton of context. It doesn't really tell me what it does. So instead of being short and confusing, now it's verbose and confusing. That's not necessarily terribly helpful. And finally, a third code example from Daily WTF. It's a great source for bad code, as it turns out. What does this code do? Is that going to return true or false at the bottom? Do we know? Can we tell? What are the things that make this really hard to understand really quickly, right? It's all the negations. Boolean not result is equal to false. It's not the result, it's the not result. And then we're assigning it or equals not something. And then we get to the bottom and we return the not of the not result. And we're negating this several times. And this actually introduces another principle that's really important. Negations are actually harder to read than positives. So anytime you're double or triple negating something, you're adding cognitive steps that future developers have to take in order to really parse, process, and understand the code that you're writing. So it's best to keep it simple. Just stay with straight positives when possible or a single negation. Definitely don't include negations as part of your variable names because that just further confuses what's going on. So we've shown some bad examples, but why do I care? How does this impact my life? Why does this matter to me or to anyone else? Can I just write my code? So the first reason is that we don't want to cause confusion. And I'm going to read a quote from SpaceX. There's a creeping tendency to make up acronyms at SpaceX. Excessive use of made-up acronyms is a significant impediment to communication, and keeping communication good as we grow is incredibly important. Individually, a few acronyms here and there may not seem so bad, but if 1,000 people are making these up, over time, the result will be a huge glossary that we have to issue to new employees. No one can actually remember all these acronyms, and people don't want to seem dumb in a meeting, so they just sit there in ignorance. And this is particularly tough on new employees. So that's one of the reasons. It's that when we are not clear in our communication, when we use acronyms, for example, we can cause confusion in a way that is hard to overcome. And one of the reasons we should care is that we're making life very difficult on new employees. We're making life very difficult on consultants and contractors and other people that are just now getting into the project or getting into the code for the first time. And the reason that is a problem is that we're constantly onboarding people onto our teams. Even in small teams, I feel like this happens a lot. There's some reasons for this. Most developers switch jobs every 2 years. on average. And 4 years is effectively a limit. As much as there are developers that definitely work at the same job for more than 4 years, that is really a high watermark for how long people stay in the same job a lot of times. We also grow, right? We're expanding our teams. We're getting larger as a team. Maybe we're hiring contractors for different things. There's a lot of reasons why we might be onboarding new people to our teams. And this seems to happen a lot. As much as this happens, this feels like a thing that maybe we want to optimize for in a lot of ways, because it can be very expensive to onboard somebody into a very complicated system, or one that is hard to pick up and understand and be able to contribute value to. Another reason is inclusivity. It's the way we write our code can make it easier or harder to reach out to people with different backgrounds, people from different parts of the world, people with different levels of education, specifically in software, right? There's a very big difference perhaps in the type of background you might have if you went to a coding academy versus a computer science degree versus a design degree or an engineering degree, or perhaps even no degree at all. Some of the very best developers I've worked with didn't finish college, and that's totally okay. But it's really important that we not create artificial barriers that restrict and make it harder to communicate with people of different backgrounds and different educations. And another reason is accessibility. The code we write, especially for things like HTML, for example, and semantic code can be a very important part of an accessibility implementation. It's really important that the code that is processed by the browser, for example, by a screen reader, is straightforward and clearly indicates intent to make it as easy as possible for automated tools to render that material in a variety of different ways. It's also very important that if the developer themselves requires accessibility tools, that those accessibility tools are able to work with that code well. So the more creative and clever we get with the way we do things, the less straightforward we are, the harder this can be. And another really obvious one, I think, that all of us can really accept is bugs. The cleaner our code is, the easier it is to read, the easier it is to avoid errors. Really simple code can be obviously free of errors, as opposed to really complex code can be free of any obvious errors because you don't understand what's going on, right? Keep it clear, keep it consistent, keep it reliable, make it easy to understand. The easier I can understand the code, the easier it is for me to figure out if there's bugs or issues or errors. Also, cleaner code, more straightforward code, can often be more testable, and writing good testable code is one way of preventing bugs. But good testable code, good consistent code, code that reads well, also helps with automation. For example, text parsing, document conversion, code generation, all these different things that we want to use to be able to do better work, to offload some of our job as a programmer to the computer. These things require us, in many cases, to follow certain standards, conventions, and these are things that are very helpful overall. Another part of communication in your code is the way we name things. And naming is just one small aspect of it, but this is very, very important, and it helps make your code more readable. So Phil Carlton had this to say: there are only two hard things in computer science: cache invalidation and naming things. And cache invalidation is basically an impossible problem, as anybody knows who's worked on it. The point he was making is that naming things is just as hard as some of the hardest problems we have in computer science. It's really hard to get that right. One way in which naming things can be really tricky is that it's really easy to introduce ambiguity, especially in the English language. Now, ambiguity refers to any word or phrase for which a single cohesive concept cannot be readily identified, at least without knowing the proper context. For example, there, there, there. Completely different meanings, but they sound the same, right? What's another example? Two, two, and two. These are examples of what makes English a really hard language to learn, but they're also examples of ambiguity. Now, these are examples of verbal ambiguity, right? If I say the word to, you have to understand the rest of the context of what I'm saying to understand which to I meant. But the same thing can happen in writing. For example, free. What do I mean when I say the software is free? How many open source software people are here, right? What does free mean in the context of open source software? As an example, the GPL clearly states that you can charge money for the free software. Free in open source generally means free as in freedom, as in liberty, not free as in beer or giving something away for free. Free to use it however we want, or free as and we didn't have to pay for it, are two different types of free, and just by looking at the word free, we don't necessarily know which one we meant. So keeping it clear is very important to avoid confusion. So here are some examples of acronyms or abbreviations or initialisms that I've run across in my career, and I want you to sit and think about the first thing that occurs to you when you see them. In my humble opinion or in my honest opinion? Maybe this is a content management system, but this could be Centers for Medicare and Medicaid Services. As an example, I once worked on a content management system named .cms for Centers for Medicare and Medicaid Services. We had CMS acronym flying all over the place and people had no idea what we were talking about. CYA can be see you later or something else. DOA, dead on arrival, do over again. What about RAM? This could be memory. This could be a truck. This could be an animal. Here in Indianapolis, there's RAM Brewery. It can mean lots of different things. GB, Great Britain, gigabyte. QuickTime, quality time. The Qt app framework. On my way, oh my word. End of day or end of discussion. Context matters. It can mean all these different things, but here's my favorite. ST. ST can mean stanza, it can mean street, it can mean straight, it can mean saint, Star Trek. In fact, there are 34 Wikipedia entries on, there can be 34 entries on ST in the Wikipedia disambiguation page. It's really hard to tell what this means. And when you see this in code, and I see ST in code all the time, it's not obvious what it means ever, basically. Because even within the context of an address, for example, ST can mean a lot of different things. So that's enough negativity. It's enough talking about the horror story, right? Let's talk a little bit about the fairy tale. What do we want the good code to look like? What are some things we can do right? So, how many of you have switched jobs at least twice? Have you encountered communication problems when you did this? Right? So when we talk about naming in particular, what makes a good name or a bad name? How do we judge a name? How do we assess code? How do we determine if it's good or not? Right? How do I know when I'm entering a new situation that I'm going to be communicating effectively to this new team? Right? As an example. So assessing is a really important part of what we need to be able to do. So how do we assess if our communication is clear? One way is semantics. Semantics is the branch of linguistic and logic concerned with meaning. In code, this refers to choosing the right words or structures to convey the intended meaning. For example, in HTML, using the correct tag, like a nav tag for navigation, instead of using a div tag for everything. It's also very important for accessibility. So in this example, maybe I use process or login, right? Do I want to process a user or do I want to log the user in? Process just says that I'm doing a thing to the user, but login tells you what I'm doing to the user object, right? Vocabulary is the words that are being used in your communication, right? They're only particularly meaningful if they exist within the known vocabulary of those reading them in the future. So for example, reciprocal. In math, this means an inverse. But in relationships, this can mean something different. It means that if you do something for somebody else, they'll do something back for you, right? Reciprocity. So reciprocal might mean different things in different problem domains. Ray. Again, in math, this is a line with a starting point, no end point. But in zoology, right, it's an animal that swims in the ocean. So those are two very different things for the same word. So the context is really important there. In insurance versus the banking industry, for example, you'll end up with a lot of the same words with slightly different definitions of meanings. So switching between industries can often mean learning a new problem domain space. It can mean kind of relearning some words that you didn't know before. So even within a tech team, we may favor certain word choices over others. And good communication may mean learning your team's vocabulary in addition to the vocabulary of whichever vertical industry you're in. Like, for example, banking or insurance or healthcare. And then the vocabulary of the tech industry as a whole. And if you're creating entirely new names, that can cause even wider problems. Failing to follow the vocabulary of your industry can be very expensive. I worked for a company a while ago that spent millions of dollars every year on custom development for integrations with other companies and systems almost exclusively. The reason they were spending this money is because they didn't follow the published industry guidelines. Because if they had, there's a lot of tools and software that would have automated all those integrations they were spending a lot of money on. So following this vocabulary can be really valuable. Intent is another thing. What do I intend when I'm looking at the code? Do I understand what the purpose of this thing is or when I might want to use it? So if I say convert time and pass it in a date, what's the conversion? What kind of conversion? Am I converting from one time zone to another, from one format to another? It's not super clear. But in this case, I'm saying local to UTC. Now I know that I'm doing a time zone conversion on that date. Now it's super clear about what the intent is and when I might want to call that function. Here's another example of intent. Check username. What am I checking it for? Am I checking to see if they're logged in, if they're not logged in, if the username's available or not available? Or I can just say it right in the function name, right? Is username available? Now I understand what that function's doing and what I might want to call it. That tells me the intent of that code. It's important when we're writing code to remove that ambiguity. We talked about ambiguity before, so let's talk about disambiguation. And this basically means to make sure that only the intended meaning is the one conveyed. A good name, for example, shouldn't be confusing, and it's entirely possible to have something be correct and accurate while still being ambiguous. So execute, for example, what can execute mean? To run a process or to kill something? There's a few different things it can mean. So we need to make sure that when we're selecting a word, we try to, for example, use the phrase run a process or run or kill as opposed to execute. Light. Well, light's pretty straightforward. It's a ray of light, or it is the light that allows us to see, or perhaps it means not heavy. So this is a case where, in the right context, it'd be totally fine to talk about light as in not dark, but we need to be really careful if we're in a warehouse application and we're talking about the weight of things, right? So we would perhaps want to use the word brightness or luminosity versus weight, for example, if we have both of those things in the context of our application. Ephemeral use. Ephemeral means temporary or for a limited time. A lot of the code we write is temporary. It's a fundamental aspect of agile development methodologies. We acknowledge that we don't know everything in advance, which means that we know that things are going to change. But we don't always know in advance when something is short-term or long-term, so it's important, when possible, that we choose naming and we choose code that has long-term validity even as things change later. So, for example, this is very ephemeral code. It's good exactly once, right? I can call this function once and it's random because I did it randomly. But the second time I call this function, it's not random anymore, and it's not helpful. In a startup, for example, you may be scrapping stuff all the time and rewriting it, but in a corporate environment, you may intend to rewrite things, but maybe this ends up in use for years. You do this function that you just intended to be a one-shot, and 5 years later, somebody runs across it, and it's like, why is this here? So let's look at a common example of this. You're working on the UI for a website. Marketing gives you branding colors. This is what you came up with from the palette. Pretty simple, hard to mess up, right? Fast forward a few months, they decide to change the secondary colors on the brand, right? No big deal. Just change a couple hex codes, boom, done. Super simple. Looks better already. But what's wrong? Okay. What's wrong? Now, I've seen this in more places than I care to tell you. I've seen this exact scenario. And now, blue doesn't really mean blue in this case. It means primary color, secondary color, tertiary color. That's what we really meant here. And maybe that's what we should have said, because originally, right, those names for those colors meant something. But when we changed the palette, it became too hard to define and replace for everything. So we just changed the hex code and didn't change the class. And now we have classes that don't mean what we thought they meant. And that's very confusing. Let's use another example of this. Right. This is a CSS class. We're using it to mean text align right. Okay. And now, first of all, if you pull in a CSS framework, there's like a 90% chance there's going to be a right class in there somewhere. With about a 50% chance it'll be implemented like this, and about a 50% chance that'll be float right instead. And just already, this is really bad. But let's look at an example of this. We use class right to right align something for numerical alignment on columns. Perfect, beautiful, fine, it works. But we also use it in this other case to right justify some text. In this case, a counter at the bottom of a text box. So the problem comes later when I decide that I want to change some of this code. I want to change the way this comment box looks, right? I changed the styling of it. That's fine. It's no big deal. The problem is I changed it on that class, and now I change it in this other place. And I don't necessarily notice this because I'm not looking there. When I'm issuing my pull request, for example, I'm only looking at the code that I specifically intended to change. I'm looking at that one use case. I'm not looking at all the other places in my application that perhaps I just impacted. And that's not going to get caught until later. So how can I avoid this? The answer is use a more specific name for that class in the first place that's specific to the intent of how it is actually going to be used. And this is a really contrived example, but I see this all the time. Just because two blocks of code are exactly the same today does not mean that they will be exactly the same forever. And so if the intent of those two pieces of code is different, even if the actual text of the code is the same today, probably give those different class names, give those different function names, give them, they're separate. They don't mean the same thing. They're going to diverge later on, just like this and this, right? Now we have a character counter. It's specific to this exact use case. I can style it how I want. It doesn't impact the other stuff. So this is an example, again, from the daily WTF of somebody that is trying to write cleaner, better code. But there's a side effect. How do you think this came about? Why would you write an update function that just calls 3 separate other functions? Well, I've seen this before, and I have a pretty good idea what happened. The company that this person worked at had realized they had a lot of bad code that was really hard to read. It was too long, whatever. So they implemented coding standards. One of those standards advocated something like keeping methods to no more than 500 lines of code each. So what happened when the next developer touched this method that was 1,500 lines long? They broke it into 3 separate functions, straightforward, simple, follows all the rules, and then did this. Problem is it's not helpful. It's a terrible refactor. It makes the code actually harder to read, but it met the criteria. So one thing that's really important is to avoid writing really hard and fast rules that everybody has to follow in order to check in code that would encourage them to potentially take a shortcut rather than taking the time to give a really meaningful and purposeful refactor or improvement to the way you would read the code. Here is an example of why typos might be bad, right? So in this particular case, you see 3, at least, different spellings of the word expiration. And I don't want to pick on anybody for spelling, but the problem is that if I were going to try to find all the cases, all the places in my code that expiration exists, I would have a hard time doing that. I would miss a bunch of those places because a simple find and replace, for example, wouldn't work. So spelling can actually be really important in our code because it provides consistency. Even if we spell something wrong, so long as it's consistent in every single place, that's actually better than right sometimes, wrong sometimes, or spelling it different ways. And there are some words, for example, color in American English versus color in British English, they're spelled differently. Be consistent in your code base, right? You got to pick one and roll with it and not be inconsistent, because otherwise it can be really hard to find some of those differences. So it's really important to have good standards on your team for how you're going to do some of these things. And so the names you choose for your variables, methods, and classes can provide a very good indication of the status of your overall architecture. Good names are one of the best indicators of clear, elegant code, because if you're easily able to provide a good name to something, it's an indication that it has a very clear intent, it has a very clear purpose. You understand why that thing exists on its own. Bad names, however, are a symptom of the fact that we're struggling with chaos and confusion. Maybe we're breaking the code down in a way that isn't actually logical or feels somewhat contrived. So that's a great indicator, but the architecture that we choose is going to reflect on the way we're starting to put that code together. And when we start to struggle with clarity in our code, we need to take a step back and figure out, why is it? Why are we having trouble conveying this concept in code clearly and concisely, and find a way to work around that? And maybe that doesn't mean writing more code or different code. Maybe that means changing the structure of some things. So this is a case, another counterexample, where variable names are an indication of a problem. So you see you have this S1, S2. And you look down a little bit lower and you see that S2 equals S1 dot replace, then S1 equals S2 dot replace, back and forth and back and forth and back and forth. Few things are possible. One of the things that's likely is that the person that wrote this didn't really understand that they could keep reassigning the same variable over and over again. And in fact, it's that they could actually chain dot replace together syntactically. There's a lot of different ways we could write this, but the way this is written gives an indication that the person writing it didn't really understand what their options were. And so they have two variables that are meaningless. They're S1 and S2. That means nothing, right? And they only use them because they didn't know how to write this in a different way. So let's talk through a checklist that we might be able to use on our own code that may help us write good fairy tale code. The first is to consider our audience. The next person who touches this code you're writing is most likely a developer who did not have, or simply does not remember, the requirements or conversations you had in writing this code. It's not in their head anymore, even if it's you. So anything that is confusing or difficult or required external conversations to settle on should be passed along to the next developer with as much context as possible. This may mean a lot of different things. Maybe it means creating a comment in your code that says, here's the reason I chose this particular approach to do the thing. It's because of this meeting or this conversation or this external requirement that's not readily obvious from looking at the code. So consider the audience. So Remember that the next person to touch this does not have access to all the external context, but they almost definitely are busy and distracted, just like you are right now when you're trying to write it. Names that you use should be specific and written in the common language of your problem domain. This may actually mean the same human language, right? It would be pretty bad if we had Russian, German, and English all in the same code base. That would get really confusing pretty quickly. Pick one. But also that we choose a common vocabulary that everybody on our team can get behind. For example, tax and quantity. Are those specific? Are those in a common language of our problem domain? Maybe not. Tax can be ambiguous, so let's be specific. Sales tax rate. Because a tax could be a rate, something we multiply by an amount, or it can be the actual amount, right? A tax rate could be 10%, or it could be $5, as an example. Quantity, we don't necessarily know what that quantity applies to without context, so we can be more specific in the way we create these types of things. But we also need to know that that quantity or that tax is in the space of the domain we're working with. If we're talking about sales tax, maybe just tax is okay. If we're dealing with lots of different taxes, maybe it's not. Actions are verbs, right? That's just a natural part of language. Function and method names should always include a verb because you're doing something. For example, sales tax, order quantity. There's no verbs here. There's no actions. We don't know what's going to be happening to that sales tax. Is it going to be calculated? Is it what's going to happen? That order quantity, what are we doing with it? So let's give that verb. We're calculating sales tax based upon whatever. That's fine. We're calculating sales tax. We know what we're doing. We're fetching the order quantity. Maybe that means we're fetching it from the database. That's fine. Now we know what the action is that's happening to the thing, not just the thing that it's happening on. Additionally, this can also help you know when you might want to use those functions. Use full words when you're writing. Abbreviations can be used, but they're best used sparingly, and they should harbor no confusion either within the problem domain or the wider tech industry as a whole. As an example, I've seen these stats. That's probably pretty straightforward. It's statistics. There may be cases where it's not clear. One of the ones that drives me crazy is in Java, in CSS, and a variety of programming languages, I see class represented with Z's. I've seen KLASS, for example, for class, because the HTML class attribute is also a reserved word in most programming languages. So you can't just use the word class, but instead we could just be more specific. It's the class name, right? Or maybe it's CSS class or CSS class name, or it's the class list, because technically the class attribute in CSS can contain is a space delimited list of lots of different class names. There's so many different things we could use that would avoid really weird spellings like this by just using the full concept or the full word. We'll mention spelling. What's a way around that? Use a spell checker and include spell checks in the code reviews. This is a really fun one. Create was a C function for at least for many years. I don't know if it's still that or not. I haven't looked, but it really means create. It was abbreviated. The E was dropped. It was misspelled, whatever. But that's can be really interesting. Refer with one R is actually part of the HTTP spec. Now, it's been updated. The spec now has 2 R's, and all of the web servers and browsers and everything now can use 2 R's, but for backwards compatibility, everything still supports refer with just 1 R. And it's there because the spec was misspelled at the time it was created, and now we're stuck with it. And whenever you have a public API that other people are going to be used, please spell that really, really carefully. But again, this means that now we have to check a couple different spellings whenever we're trying to find things in our code. Try to avoid creating confusion by these sorts of misspellings. When you're writing comments, and I encourage you to write comments, write lots of comments. Comments are fantastic, but they should explain why or how. Only explain what if that understanding is buried within third-party code. Never ever duplicate your code with your comments. So for example, this would be a bad comment. Iterate over the list of items in the order. Well, yeah, so I've got this order and I've got items on the order that I'm going to check out with, whatever, I can see a for loop or a for each iterator and know that this is what's happening. This is not helpful. This is code. However, I might not know this. What I'm doing is calculating the sum of quantity and price for each item for verification per this specific story or issue or ticket, right? This is helpful. This tells me where to go look for information about this later if I want to change it so that I don't make a mistake or screw something up, right? That's valuable. So we also often use namespacing as part of the context of the information we're trying to convey. So things like business.state or total don't have a lot of context because state could mean, for example, an address, right? Like Indiana, Illinois, Missouri, Michigan, whatever. Or it could be the state of the business. It's active, it's operating, it's delinquent, it's suspended, it's terminated. Those sorts of states, right? And the total of what? Total tax, total whatever, it's order total. So you can use namespacing, right? With the dot prefix is pretty common in our code. Use deep namespacing to convey that extra context. We don't necessarily just need to use really, really long variable names when that namespace is available. This is common in database table names in SQL, for example, class names in Java or JavaScript or C#, stuff like that. So namespacing is a great way to provide that context. In my opinion, though, one of the very best ways to start making improvements in your code base and on your team is to put together a checklist of specific naming recommendations and code quality recommendations and things you want to do. This can be a glossary of project vocabulary. Make a checklist for your code review process. And if you're not doing code reviews, I strongly recommend that you do it. And remember that code reviews don't exist to remind everyone how smart you are. This is not supposed to be an ego trip. The purpose of code reviews is to provide consistency, to make sure that multiple people agree that the code that was written is clear and understandable. It's also an opportunity to provide mentorship, but it's not just mentorship for senior developers to review the code of junior developers. Let your newest developers review the code of your most senior developers, and you're going to learn that they spot things and see things that you missed, and they're going to have really great insights into what's really confusing in the code and what's really simple and straightforward. And it's going to make your code better if you do that. So, if this is a fairy tale, we all want to live happily ever after and code happily ever after. What does that look like? Well, we need to remember that our code that we write is a form of communication between developers. It's not just giving instructions to the computer. So when we're writing our code, we've got to think about the other person, right? That communication then should be clear and succinct and specific. We need to make sure that it's the next person that comes along, even if it's us 10 weeks from now, 6 months from now, that we're able to pick it back up and that we understand what was going on. And the reason we want to do this, the real value here is that readable code supports inclusivity. It supports accessibility. And it's good for the company's bottom line. It's always going to be cost effective to spend 5, 10, 15 minutes, an hour or 2 hours, 3 hours making the code more readable, because you're always going to spend more time reading code than writing it. No matter how long you spend on it, take the time to make it readable. And in order to accomplish all of this, create team agreements, get the whole team on board, make specific decisions about steps you want to take to make the code more readable, actions you're going to take, agree to those, and then support those, reinforce those through code reviews, not through automation, because automation for code quality isn't very forgiving for the fact that there are going to be exceptions in many cases, but use code reviews so you can all agree on what's going to happen. So, we've gone from horror story to fairy tale. Hopefully, now you're ready to write code that people want to read, and I want to thank you very much for listening to this entire presentation. This is me. I appreciate you being here. Have a great day.